Hello everyone. Welcome to another episode of my YouTube channel, Data Science with Sam. This video will cover another exciting topic on neural network. As you remember, in my previous video, I spoke about neural network components. There are three major components such as input layer, hidden layer, and output layer are kind of like a main building blocks of neural network. And I also covered forward propagation and backward propagation techniques in my previous video. Now you know how these two propagation techniques played crucial role to make your neural network learn the training data. Now, when you train your neural network using these two propagation techniques, you must be wondering that do we have to provide any manual intervention? Because as we know in neural network, the feature extraction process happens automatically. But still, we need to pass some parameters into a neural network so the model will understand the data better, it can minimize the loss, and it will improve the performance and provide better prediction. So in today's video, I'll talk about those hyperparameters only. So in next time when you build your neural network, you will know which are all the main hyperparameters you need to pass to your model. But before proceeding further, I would definitely recommend you to go back to my YouTube channel and watch the previous video because there are certain stuff you won't be able to understand if you never know about what is input layer, hidden layer, output layer. So I would definitely recommend to go back, watch that video before you go to the next section. And don't forget to smash the like button and subscribe to my channel because there are more exciting data science related videos are forthcoming, and you will also get to know about how you can build your neural network using PyTorch and TensorFlow in my upcoming videos. So please subscribe to my channel and let's go to the next section to learn about hyperparameters. So as you all know that neural network performs feature extraction process automatically. But there are still some parameters that we need to pass manually during model building phase. For example, learning rate is one of the most crucial hyperparameters that we need to pass through neural network model because that learning rate will decide how your neural network will perform on the trained data, like the data we're actually passing it through input layer. But there are two caveats. If your learning rate is very small, your model will take enormous time to train on the input data and provide prediction accordingly. On the contrary, if your learning rate is too big, then your model will jump to conclusion, which will lead to a very bad prediction. So finding an optimal learning rate, which can improve your model, is a very challenging task. But we got to actually follow some trial and error approach to find out the optimal learning rate that will help improve the performance of your neural network model. So always watch out for learning rate because that could be a game changer for your neural network model. So let's move to the next section to learn about more hyperparameters. Another important hyperparameter is activation function, which is responsible for empowering neural network because it helps neural network to decide on which neuron will be activated for prediction purpose. So if neural network won't use activation function, it will adversely impact the model performance. So think about activation function as a funnel. Okay, so it will basically filter the main neuron with the main key features, and those key features will be responsible for performing the prediction in the later stage. So now this neural network activation function is usually a kind of a nonlinear function, and it also increases the degree of freedom of the learners. It's also enabled the model to perform better and also make it stable and generalized more on a different unseen data. So it actually helps to improve the accuracy. So there are some activation functions which you use for our neural network model building phase, such as ReLU, which is we call it a rectified linear network. And also we use sigmoid function. So sometimes we use Gaussian function as activation. But if you consider the popularity, we mostly use ReLU and sigmoid as activation function for any such neural network. We will talk about it more in my next videos when I will give you a hands-on experience of how we can build a neural network from the scratch. So next, move on to the next section for another hyperparameter. Another important hyperparameter is cost function because it used to calculate loss given the real and observed results. Let's think about the backward propagation technique that I mentioned to you in my previous video. So during backward propagation technique, neural network model try to minimize the loss during the training phase. Now, how it determines the loss means the difference between the expected output and the actual output. Well, cost function helps neural network to make that calculation. Without cost function, it's difficult to understand that how accurately your model is performing. Most of the cases, cost function integrated with an optimizer to help perform the calculation during the neural network training phase. Some famous cost functions are quadratic cost, which is related to root mean square, a very popular statistical measure. One of my favorite statistical measure or the cost function is cross entropy, which usually I integrate with either Adam or SGD optimizer. So most of the cases, a cross entropy cost function can be differentiated based on how many classes you're trying to predict. So if you're trying to predict like a binary classification model, so in that case you use binary cross entropy. But if you're trying to perform a multi-class classification exercise, then use I think categorical cross entropy. There's another important cost function that's kind of becoming popular recently. It's called exponential cost function that you can use with AdaBoost optimizer. So AdaBoost optimizer are actually one of the best performing optimizer right now because it seems like in certain cases it performs better than SGD and Adam. So in most of the cases, actually data scientists are considering it as a combination of SGD and Adam right now. In one of my videos in next few weeks, I'll talk about optimizer because that's also a very important aspect of neural network model. In most of the cases, I personally prefer SGD and Adam, but check out this AdaBoost because that optimizer is becoming very popular in recent days. Now let's move on to the conclusion section to wrap up this video. So today's video covered a very brief overview of hyperparameters, but at least it gives an idea that what are the parameters you need to select manually for your neural network model. And also there's one more hyperparameters that I need to share is called epochs or iterations, because you need to train your neural network for certain iteration to get a better results. So finding epochs or iteration count is also a very good approach because it's sometimes in some cases some models perform better if you use a smaller number of epochs, but in some cases you may have to go for a larger number to get better accuracy. So epochs or iteration is also very important hyperparameters, so don't forget about that. So now you must be wondering that you learned neural network components, you learned about hyperparameters. So what's next? So now I need to give you a hands-on experience of how to build a neural network model from the scratch. So I'll cover that in my next video. And I'll basically start with the convolutional neural network model, which is most popular and most applicable in real world. So stay tuned for that. And also just look down in the caption section because I provided some learning materials that will give you more idea about neural network hyperparameters. So now let's wait for the next video, and also please try to learn more about neural networks because that will be helpful for your data science work in future, because deep learning has a long way to go. Okay, because we just taking a baby step in that, and there's so many things we can explore using deep learning. So stay tuned. Till then, goodbye. And don't forget to like and subscribe to my channel because more videos are coming.